Okay, so for 49, there are 1, 2, 3, 4, 5, 6, 7 colors, and we want to arrange all 7 of them. So there are 7 possible choices to pick our first color, and then we're not going to pick it again. They kind of assume that, which is kind of mean, but we want to arrange these colors. So we pick one, 7 possibilities for our first, 6 possibilities for our next, 5, then 4, then 3, then 2, then 1. And just multiply those all together. 7 times 6 times 5 times 4 times 3 times 2 times 1. Come on, calculator. We get 5,040. And that's that. 53. We're looking at the word education. And we want to know how many ways we can arrange these. Now we have to be very careful with questions like these because if any of these letters repeat, then there aren't as many combinations as you would think because they would be the same. So, but I think all these letters are different. E, D, U, C, A, T, I, O, N. So they're all different. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters that we're arranging. I'm just going to write 9 factorial. On that last problem I did, I could have written 7 factorial because that was 7 times 6 times 5 times 4 times 3 times 2 times 1. This is the same idea. I have 9 letters that I want to arrange. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possibilities for my first. Then I can't pick the same one again, so 8 possibilities for the second. 7, 6, 5, 4, 3, 2, 1. So 9 factorial is the same thing as 9 times 8 times 7, blah, blah, blah. And if we do that on our calculator, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 362880. And the reason I wrote it this way is because in the next problem, when there are repeats in those letters, we're going to have to be more careful, and this is a nice way to write it. So let's look at the next one. Actually, before I do that, I want to do 56, because I don't like 57 because it goes straight to digits. So let's look at these. These are classically called Mississippi problems. MISSISSIPPI. And if we wanted the number of arrangements of these letters, we have a lot of repeats. So there are 11 letters there, but we have to divide out by the repeats. There are 1, 2, 3, 4 i's. So I'm going to divide by 4 factorial. 1, 2, 3, 4 s's. So another 4 factorial. And 2 p's. So another 2 factorial there. And the rest of them are just 1, so 1 factorial would just be 1 anyway. So it's the total number divided by each of the repeats. So if you were to actually calculate this out, I'm going to write out 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5. I want to stop at 4 factorial to let it cancel out with this 4 factorial on the bottom. But I still have to write out that 4 factorial and that 2 factorial. So this 4 factorial is canceling out with that. Then this 4 factorial is 4 times 3 times 2 times 1. And this factorial is 2 times 1. So when you go to simplify this, like everything on the bottom will end up canceling with something on the top. So I can divide the 4. If I divide the bottom by 4, I get a 1. If I divide the top by 4, the 8 by 4, I'll get 2. If I divide the bottom by 3, That'll go away. Top by 3, I'll get a 2 there. I'll let this 2 cancel with that 2. I'll let this 2 cancel with that 2. Taking care of the entire bottom. So now on the top, all I need to multiply is 11 times 10 times 9 times 7 times 5. So we're getting 11 times 10 times 9 times 7 times 5, 34650. So 34650. So that's the Mississippi problem. And the next one we're going to do looks a lot like that, except it's with digits instead of letters. So if I look at 57, they have the number 9, 8, 7, 6, 6, 7, 8. And don't let the fact that their numbers confuse you. They're just things that we want to arrange. There are 1, 2, 3, 4, 5, 6, 7 letters that we want to arrange. And just divide out by the repeats. There are 2 8s, so 2 factorial, and 2 7s, so another 2 factorial, and 2 6s, so another 2 factorial. So 7 digits total, no repeats on the 9, but 2 8s, 2 7s, and 2 6s. 2 8s, 2 7s, 2 6s. So working this out, this is 7 times 6 times 5 times 4 times 3 times, I'll stop at 2 factorial and let that 2 factorial cancel with the 2 factorial down here. But I still have to write out this 2 factorial and that 2 factorial. So this one is 2 times 1 and this one is 2 times 1. So if I start canceling, everything in the bottom should cancel somewhere. I'll divide this by 2 to get a 1. I'll divide this by 2 to get a 2. And then I'll let this 2 cancel with that 2. So now all you have left on the top is 7 times 6 times 5 times 3. And if you do 7 times 6 times 5 times 3, you get 630. So that's that. So, 61. In how many ways can the manager of National League baseball team arrange his batting order of 9 players if the pitcher must bat last? So he's got 9 players, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the pitcher must bat last. So this guy is fixed. We know there's only one possibility for him. So for the first guy at bat, he can be anybody but the pitcher. So there are 8 possibilities for him. And then the next one, 7 possibilities, then 6, then 5, then 4, then 3, then 2, then 1. So this first guy, out of the 9 people total, he can be anybody but the pitcher. So 8 possibilities. This guy can be anybody but the pitcher and whoever went first, and so on. So just multiplying all of those together, 8 times 7 times 6 times 5 times 4 times 3 times 2, we get 40320. And then for B, if there are no restrictions, and you have 9 players, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 possibilities for the first guy, 8 possibilities for the second, all the way down the line. So if you multiply those together, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, there are 362,880. And that's that.